So today's lesson, ladies and gentlemen, we are going to be looking at solving equations with variables on both. Let's try this now. So we're going to be solving equations with variables on both sides. So our gist of our notes is pretty straightforward. To solve an equation with variables on both sides, you must isolate the variables to one side of the equal sign, and then the constant terms to the other. We're going to separate, get variables on one side of the equal sign and everything else to the other. Straightforward, to the point. Okay? Now, the method about going about and doing this is pretty easy, I think. Some of you might not think it is. But it is following the same rules that we use for solving a one-step, two-step, multiple-step equations. When we want to take something and move it from one side of the equal sign to the other, what do we have to do? Yeah? If we want to move it, what do we have to do, though, usually?
Do the same thing both sides?
Yeah, we have to do the same thing to both sides. So either we're going to subtract it. If we subtract from one side, we have to do it from the other. If we have to divide it, we have to divide from one side to the other. Okay? So our examples that we have up here, we're going to be seeing three problems when we do this. This is the first one, just solving using, we're having variables on each side of the equal sign. So if you look at it, we have x plus 16 equals 9x. Well, what I want to do is isolate and get rid of that 1x on the one side. So I minused it. So whatever I do to one side, I do to the other. If you simplify it down, all the constants are on one side, all the variables are on the other side. Now it's a one-step equation. It's pretty simple. 8x, so we divide 8 from each side, we get x equals 2. The other examples up here, sometimes when we're working through multiple step equations, you're going to come up to a point where you have no solution. So as you're working through the problem, you get to the point where the two numbers on each side, there's no variables anymore because they canceled. Now we just have two numbers that are not equal to each other. If we get that, that is called a no solution, because if you take a look at that example up there, 5.5 does not equal 4.5. That does not equal. So if they don't equal each other, there's no solution. On the last one, we have many solutions or infinitely many solutions. If you take a look at this, we get all the way through and we end up 0 equals 0 or 15 equals 15. Well, does 15 equal 15? Yeah, so if 15 equals 15, we know we have many solutions. We will go through multiple examples of these. Now, I'm going to change it up a little bit today. I'm going to go through the first example, and then after that, I'll let you guys walk through and do some. So if you want to get this example on a Post-it note, put it into your notebook along with your notes. I strongly suggest it. I believe I threw enough Post-its at your table where you can either split a pack so everyone has their own and go through there. Okay? All right, so the first problem that we're going to look at today to try to solve an equation with variables on both sides is 15 minus 2x equals negative 7x. Okay? Let's see if everything is working right today. All right, here we go. 15, 2x equals negative 7x. All right, so based on our notes, we want to isolate the variables to one side of the equal sign. So just like we did before, solving one step, two step, or multiple steps, I'm going to build that wall. I'm going to put it down the middle so I know whatever I do to one side, I have to do to the other. Now, this is almost like saying we have a 0.5 rule. If you guys remember our rules, and I have them listed right behind Olivia and Olivia. That's kind of cool that you two are sitting next to each other. We have the 0 rule, take care of all the parentheses, fraction bars, things like that. The 0.5 rule is isolate the variables. So let's isolate them. Which side would you try to move the variable to? Are we going to take 2x right here, negative 2x, and move it this way, or are we going to move this negative 7x? Which one would you guys like to move? Connor?
I'd move the 2x because I just tried it and it doesn't work if you move the 7x.
Well, it does work. It does work. It's just you're deciding to take the long route to Grandma's house instead of taking a shortcut. Okay? If you already have one variable that is isolated by itself and no other constants next to it, try to move the other variable to that side. The other thing I look at is if it's negative, I want to add. I'd rather add than subtract. That's just me. And Miss Cornelli I think you agree with that. It's a lot easier to move a number if it's negative because you add it instead of subtracting it.
See, I always move the number that would prevent our variable from becoming a negative.
Yeah.
In this case,
It's going to stay anyways.
But it's easier to move the smaller number.
All right, so in this case, we are going to move that negative 2x. So we have a negative 2x. How do we isolate or get rid of that from one side of the equation?
Turn it into a positive.
So if we turn it into a positive, we're going to add 2x to this side. That cancels that out. We still have 15 on this side. Equals, we're going to add 2x to this side because if we do it to one, you must do it to the other. So now we take a negative 7x and we're going to add a positive 2x to it. So Jason, what am I going to get when that happens? You're going to get negative 5. So now we have negative 5. That x is still there. It does not disappear. The variable is still there. So now we have a simple one-step equation. Okay? What do we have to do now? Oops. Let's choose that one. The rest of you go away. Now what do we have to do? Jaden.
Divide by -5.
So I'm going to divide by negative 5 to this side. Cancels out, leaves us just with x. And we have negative 5 over here. And we're dividing. That line that I'm putting underneath it is showing division. I see a lot of students still doing this. I don't know if you saw that, Ms. Cornelli.
I did, but it's so much easier to use that fraction mark because then they just come on.
Remember, fractions are division problems.
Yeah.
Okay? All right, so we have a positive 15 divided by a negative 5. Yeah? Negative 3. So our solution to this, it's a one solution. There isn't multiple solutions or no solution, is negative 3. Okay? Any questions on this example? Now's the time to ask. Yeah? No? All right. All right, ladies and gentlemen, we're back on here. Here we go. So our second example. Now we are going to take it to the next level and put our distributive property in here. So if you want, grab a sticky note. This is another good example of one with distributive property and answering a variable on both sides. I'm going to walk them through on these examples. Okay? So, once again, if myself or Miss Cornelli are up here, we need Mel's to be quiet.
Another 100.
Okay, so we're going to rewrite this to start us off. Oh, that's what's going on. Mike is dead. All right, so with this, ladies and gentlemen, we have distributive property to start us. Okay, so with the distributive property, we have to make sure that we're taking care of parentheses just like we have in the past. So, to rewrite this equation, it's negative 2 times x, so we have negative 2x, and we got multiple colors going here. This is where I see a lot of problems with students. This negative 2 is still connected with it. So when we take negative 2 multiplied by negative 5, that minus sign is in front of the 5, that goes with it. I think you said something about eating it up or something. Didn't you were talking about that, trying to figure out a way to show that this negative was going with that?
After it was distributed. Because you could still write it minus that negative 10, which a minus a negative 10 is, I don't know, Mrs. Potkay's world, it was chop chop.
Okay. So, here then, 6 times 2 is 12. 6 times negative 1/2. When I see a negative 1/2, either I'm multiplying here, so it's almost like dividing by the denominator, because it's that 1/2. So in this case, it's 6 divided by negative 1/2. It's going to be half of 6. So what's half of 6? 3. But we still have that negative, so it's negative 3x. So now we have it set up like we did before. Okay? So we took care of parentheses. Now what we need to do is isolate the variable to one side of the equation. Well, which one do you want to move? Yes, Hunter.
Let's plus add 2x.
You're going to add 2x?
Yeah.
Okay. They're both negative, aren't they?
Yeah.
So in this case, I would probably take the larger one.
Oh, okay.
And I'll show you why. Okay, I'm going to add 3x to this side.
Technically, that would be the smaller one.
Technically, it is a smaller one. Larger, just integer by its or absolute value. Larger absolute value. There we go. Okay? So cancel that. We're left with 12. I'm going to add 3x to this side. So what does that do now? We have a negative 2x plus 3x. Yes? Gives us 1x. So now we're back into the positive. Plus 10. Now, if we look at this, are all the constants on one side of the equation? They are? We're not. Is x by itself yet? We've got to isolate x. We want this by itself right here. So in this, we need to do what?
You threw in a new word in it.
Oh. With isolating here now, what do we have to do to get rid of everything by the x? Ashley. Inverse operations, which means that we're going to do what? We're going to subtract 10.
To both sides.
Whatever we do to one side, we do to the other. 12 minus 10. Jaden?
2.
2. So,